and welcome to our Defeat Diabetes webinar. And our guest today is, I'm sure, someone you're very familiar with, my co-founder of Defeat Diabetes, Dr. Paul Mason. Good day, Paul, and Happy New Year, and it's great to chat.
Good morning, Peter. I'm always delighted to be here. I always love our conversations.
Indeed, yes, so do I. I never get a word in, but that's okay. Paul's he's the clever one among us. So, yeah. So, how's your New Year started off, Paul?
Oh, it hasn't been too bad at all. I've had a bit of time. You've probably seen I've popped out a few more tweets than I normally do. It's a little bit of downtime means I get to get into the research and on social media a little bit, and a bit of time with the family. It's all good fun.
Very good, very good. Okay. Well, we're going to talk about weight loss today. We tend to focus, a lot on diabetes, and obviously there's a lot of overlap between managing diabetes and managing weight loss and so on. But it'll be good just to sort of focus completely on weight loss because obviously it's a really important issue for a lot of people, and so it's something we need to do a real deep dive into. And who better to deep dive than Dr. Mason? So when what we're always told, I guess, going through medical school and still an awful lot of people believe that weight loss is pretty simple, really. It's just a matter of less calories out than calories in. So the whole sort of calories in, calories out sort of theory. It's just about calories. And if only it were that simple, hey?
Well, I mean, it's complete and utter nonsense. And the problem is the reason it's been able to get so much traction is because it is actually based in fact. It's actually true that for you to gain weight, you actually have to take in more calories than you're burning. It's a simple matter of calorie balance. But why it is complete nonsense is it describes the problem, but it doesn't explain the problem. So what do I mean by that? Somebody who's gaining weight, yes, they're consuming more calories than they're burning. But why are they consuming more calories than they're burning? And this is what is missing from the conversation. This is why the whole calories in, calories out does not work. It doesn't help us deal with obesity because it doesn't explain the problem. It doesn't tell us what to do. It just tells us what it is.
Okay. Well, I've got a feeling you're going to now explain why it's not important or why there's other issues involved.
Well, I mean, look, you've been a doctor. You've interacted with thousands of patients, and you've spoken with lots of people, and you know what the typical patient experience is when they go to a doctor. They go to the doctor and they say, "Doc, I'm having trouble losing weight. Can you please help me?" So, as a doctor, what do? We invoke sins. We say, gluttony and sloth. You're lazy. You're greedy. It's all on you. Because it's a matter of calories in, calories out, we assume that's entirely under your control. All you have to do is eat less and exercise more. And if you can't do that, that's on you. So we're basically gaslighting the patients. We, that's all the calories in, calories out myth is. It's an excuse to put the blame onto the patient for something which most certainly is not entirely in their control. So, have you ever heard of the thyroid hormone? I'm guessing you've done a medical degree in that was 1800s or something. You've probably heard of it. So, we all know that if you have an underactive thyroid gland, that can lead to weight gain. So, what is the thyroid hormone? It's a hormone in the body. So, we know that if we alter this particular hormone, we can affect our weight gain. What about a condition called Cushing syndrome? We associate it with these very unflattering terms, moon face and buffalo hump, which is basically, references to the abnormal distribution of fat that we get with this condition, with Cushing syndrome. What is Cushing syndrome? It's when you have too much of the stress hormone, cortisol. It is absolutely without a doubt that too much or an imbalance of certain hormones will cause weight gain. And the fact is, without a shadow of doubt, the king of obesogenic hormones is insulin. And, this hormone drives fat storage and it also impairs our ability to burn energy. So, you know, you've had type 1 diabetic patients, I assume, Peter.
Yep.
So how do they present? So let's talk about a type 1 diabetic patient. They do not have enough insulin on board. Their, their bodies actually don't make enough of this hormone. And we do need some of it. Without it, we die. It is still a very important hormone. So if somebody's body's not making insulin, how do they present?
Well, with weight issues usually. Yeah.
They're emaciated. They're
Mm.
fading away. They're literally starving before your eyes. No amount of food that they can eat will stop them from starving to death. Now, that's an extreme example, but that basically speaks to the point that without insulin, you don't gain weight. And a lot of type 1 diabetics, they actually know, and I've spoken to several as patients, who, when they start the life saving insulin therapy, they notice that their weight increases substantially. So much so that a lot of them actually deliberately underdose with their insulin because they know they can stay skinny if they do that. And if they take the prescribed amounts of insulin that their doctors would have recommended, they'll often get, they'll develop obesity. So we absolutely know the ability of insulin to gain weight. And most type 1 diabetics, they have to pick an area of their body to inject. And one of the most common areas we tell them to inject as doctors is actually down in the lower abdomen down here. And what will happen if you inject in the same site long term with a large amount of insulin, that will stimulate localized fat accumulation, something we call lipo, meaning fat, hypertrophy, meaning excessive growth. And the lipohypertrophy in the lower abdomen action often resembles breast tissue. It often looks like breast. That's how localized and significant these fat accumulations under the action of insulin are. And so I guess then the question is, well, how does insulin do this? And well, it does three important things. And I want you to look at this through the lens of calories in, calories out. Because as I said, calories in, calories out describes the problem. It describes what is going on, but it doesn't describe why. If we look at it through the lens of insulin, we can begin to understand the why. So insulin does three important things. First of all, it gets fatty acids in the bloodstream and it pushes them into fat cells. It takes sugar in the form of glucose in the blood and pushes it into fat cells. And these fatty acids and the sugar will combine together to be stored in the form of triglyceride fat. So there's two steps. And the third step is to absolutely inhibit any ability to actually burn that stored fat. So if you think about this in the context of calories in, calories out, we can see that the insulin actually forces the energy into the fat cells, and it also stops it getting out. So of course, if you have an excess of insulin, you're going to end up with this imbalance between calories in, calories out. But now we know why. It's because of the insulin. Now, I guess the question is, what increases the level of insulin in our body? And I know you know what this is. So,
Indeed. Well, I mean, I think that's the obvious thing is we know that insulin is secreted in response to ingesting carbohydrate.
exactly. So, for the same amount of calories in a given food, carbohydrates will release about twice as much insulin as will protein, and much, much more insulin than an equivalent amount of fat. So we know that if you're on a high carbohydrate diet, and I guess what kind of things are we talking about with carbohydrates, Peter?
Well, there's two types, isn't there? There's the sugars, and that we see in soft drinks and so on, and then there's the starches, which are broken down into glucose and absorbed, and therefore the only difference between the two is that one takes is a bit slower to be digested and to respond, but it's
But
still
they
all
both end up
basically
as sugar
glucose.
in the blood.
Yeah, yeah.
And we often assume we use the term complex carbohydrates to refer to the starches under some misguided notion that they're somehow magically healthy and they don't turn into sugar.
Mm.
So you'll remember the study that Ludwig did, where he said, okay, well, if insulin and carbohydrates and so on and so forth is so important, he put people on low carb diets and compared them to subjects on high carb diets, and he found that the differences between the two at either end of the spectrum was 300 kilocalories a day of energy expenditure. So the subjects on the lowest carbohydrate diets were burning an amount of energy that was equivalent to riding a bike for an hour a day. And this is without any exercise. What it meant is that the subjects on the low carb diet basically were burning 300 kilocalories a day extra for free without any extra effort. And
What's the explanation for that, Paul?
well, because when you eat less carbohydrates, the body releases less insulin. And remember that insulin promotes fat storage. It pushes energy into your fat cells and it doesn't let the energy escape your fat cells. It basically keeps it there. So, again, think about this in the context of the calories in, calories out hypothesis. So, by going on a low carbohydrate diet, you're able to lose that much extra energy. And here's the kicker: these subjects did this without any compensatory increase in their appetite, which, by the way, almost always happens. Ever heard the term working up an appetite? So, so this whole thing is like, calories in, calories out. If we just look at it simply from the perspective, well, you just need to exercise more. Well, half of the people who are going to exercise more are going to find that they're going to be hungrier, and they're going to have even more difficulty in regulating their appetite. Whereas simply by eating low carbohydrate diets, the subjects in this study were able to increase their energy expenditure without any need to increase their energy intake.
So you mentioned exercise. Let's have a little chat about exercise because you know exercise is obviously important for health. I think we all agree with that. We encourage exercise, but what about exercise for weight loss?
So it's generally ineffective. If we study it, we do find that if you go make a concerted effort and you do regular exercise, especially a combination of exercise where you build your muscle, then you can lose a few kilograms. But the trouble is, it doesn't address the root cause of the problem. Well, not to a large degree. It does, to a degree, help insulin work better it, through a different pathway. We won't bore you with the details, but it does actually help remove a bit of sugar from the blood. And basically, what happens every time you contract a muscle, that actually stimulates the muscle to take sugar out of the bloodstream, and it needs to be resistance contractions that do that. High resistance is much better at doing that than a gentle walk or so on and so forth. So exercise is good to a degree. It makes you healthier, it makes your bones stronger, it helps with depression, strengthens your heart. I mean, there's a long list of the benefits of exercise, but significant weight loss, unfortunately, is not one of them.
Yeah, and it makes you hungrier, as you said. That's the problem. One of the problems.
Now, the other problem, so we've got the problem where, okay, if you eat certain foods, your body's going to release more insulin. We know that. But there's a natural state. Well, it's not a natural state, it's a pathological state. It's a state associated with disease. It's associated with most modern chronic diseases. And that's called insulin resistance. So the job of insulin, the job of any chemical in the body, really, you have a chemical and then it has to have what's called a receptor site. It has to have something that it can go to work on. That's where it does its job. Now, the receptors for insulin, we call them the insulin receptors, in this condition of insulin resistance, they don't work as well as they should. And that forces the body to release even more insulin than it used to. Now, the problem is that insulin is not working very well at the liver. It's not working very well at the muscles. So when it's not working well at these tissues, the body releases more insulin. But do you know where insulin still keeps working? In the fat tissue. In the fat tissue. So insulin's not working in these other tissues. You end up with excess insulin and it's focusing its efforts on the fat tissues. So we're stuffing it full of fat and we're not letting that fat escape. Now, there's two key dietary factors that contribute to this insulin resistance. So you alluded to one of them before when we talked about carbohydrates. You said we've got the complex starchy carbohydrates and we've got the sugary carbohydrates, the table sugar, the sucrose, the high fructose corn syrup. By the way, the cane sugar that we have in Australia is near identical in terms of fructose and glucose to high fructose corn syrup. There's really no difference. They're both quite toxic. Now, if you consume an excess amount of sugars, it's very prone to causing what we call de novo lipogenesis. In English, in plain English, this means your body will turn sugar into fat. And some of those fat compounds, they're what we call lipotoxic. So lipo meaning fat, toxic speaks for itself. And they actually damage the insulin receptors. So when you're having a lot of sugar, that actually damages the insulin receptors, and it means that your body needs to release even more insulin to do the job because it's not working properly. And we know the consequences of having too much insulin is going to be weight gain. Now, there's one other thing that is a significant, I believe, a significant contributor to insulin resistance, and it's not often talked about, and that's seed oils. Now, seed oils actually have a type of fat in them. It's very similar to the toxic fat produced by sugar consumption through the de novo lipogenesis. And the toxic fats in seed oils can also damage how the insulin receptors work. So if we have processed foods, which is rich in sugar and rich in seed oils, and I promise you most all processed foods contain seed oils, then that is just a 1-2 punch on our insulin receptors. They don't work properly. We're going to end up having elevated levels of insulin, and the consequence of that is going to ultimately be obesity. Just you might be thinking, well, can insulin resistance really matter that much? And yes, it can. So they did a study where they took some young adolescents and they followed them up over a period of 8 years. And they assessed them at the start of the 8-year period to see how insulin resistant they were. Do they have high or low insulin levels? And then they looked at them at the end of the 8-year period and they said, did you have high or low insulin levels? And when they compared the subjects who had the lowest insulin levels, not super low, just in the bottom 25%, which is not particularly low, the subjects with the lowest insulin levels had a 2% chance of becoming obese over that 8-year period. Can you guess what the number was for the subjects in the top quarter for insulin levels, the highest insulin levels?
Well, significantly more than 2%, that's for sure.
72%. Honestly, I mean, this is absolutely a staggering figure. A 36 times increase risk of becoming obesity because of the association of high versus low insulin. If you doubt the power of hormones, especially insulin, to gain weight, then you really ought not. The data is there, the science is there. We've got dozens and dozens of paper that repeatedly show these same findings. Now, you might be thinking, yeah, but how can a chemical just change your behavior like that? So, and we're sort of thinking, well, because eating, it's a volitional action to eat. You actually have to get your hand and you have to bring something to your mouth, completely in your control. You think, well, that's not controlled by chemicals, that's controlled by me. Well, let's look at a more extreme example. Breathing. So can you take a breath and hold it? Of course you can. You've got control of your breathing. Now, if I ask you to hold it for 5 minutes, you'd say, don't be stupid.
No.
If I said hold it for a minute, you probably wouldn't. What would happen if I said, I'll give you $1 million if you can hold it for a minute?
No problems at all.
You might be able to. So sure. And what is it that's driving our desire to breathe? Well, that's a chemical desire. It's driven by carbon dioxide largely, a little bit by oxygen, a little bit by hydrogen, but really it's carbon dioxide. And while we can override our natural inclination to sort of want to listen to these chemicals, eventually at some point it's going to be irresistible. We're not going to be able to resist. Now, eating is a much less extreme example, but eating and hunger, these behaviors are largely driven by chemicals. So, I've got patients who, have been able to control their weight on low fat diets in the past. They come and see me and they've said, yeah, I used to, for 20 years, I had the low fat diet. I followed the food pyramid and I could maintain my weight. And I'll ask them about, well, how did you do that? And invariably they were white knuckling it. They were struggling every step of the way. And almost without exception, if I asked them enough questions, they were displaying features of restrictive eating disorders. And it's really not a good advertisement for, the food pyramid or the calories in, calories out mantra, when the only way that you can maintain a healthy body weight over a couple of decades is with an eating disorder. So, yes, you can fight it. You can fight these urges, these chemical urges to eat, but only for so long. And invariably, most every single one of these patients who had been able to do it for, 5, 10 years, however long it was, they would eventually fail. So the reason is we have to understand the chemicals in our brain, that neurotransmitters and hormones, they're sort of the same, um, that drive these behaviors. So our modern food environment is designed to be addictive. So you talk about a beautiful concept. You talk about real food. And I've heard you use many different examples. You say, well, if your grandma wouldn't recognize it as food, if it's got numbers on the label, if it's you have used a term of a chemical storm, and so on and so forth. And this is absolutely true. But the point is, the modern foods, modern processed foods, they are engineered. They are crafted to be addictive. They focus on what they call the bliss point. They get the right amount of sugar, mix it with a bit of fat, enough salt. They focus on the mouth feel, how it feels in our mouth. And this engineering is done to make it as palatable and as addictive as possible. So it relates to two key chemicals, dopamine and serotonin. And these chemicals drive human behavior. They drive our eating behavior, and they drive our desire for procreation. And these are the two behaviors which the survival of the human species is dependent on. In effect, we are hardwired to chase these chemicals. Now, there's several health conditions that can actually lower this level of chemicals in our brains. And when these chemicals are lowered, our desire for them is even stronger. So, how do we get these chemicals? In the modern environment, how do we access these chemicals? Well, it's addictive foods. Remember that it drives eating behaviors. The most ready way that you and I can access dopamine and serotonin in our modern environment is to eat junk food. And that will give you a transient respite from feeling lousy. Now, obviously, it's just going to, lead to an ongoing cycle, and it's going to compound the problem in the long term, but you will get a brief respite for how you feel. And that is the scientific explanation for comfort eating, for emotional eating. You're quite literally getting a warm hug from the food. It's making you feel transiently better. And the modern food environment, where we've got these junk foods available that hijack our natural state, our natural hardwired state to chase these chemicals, we get hijacked by this addictive food. The simple fact is that for somebody who's overweight, there is no safe amount of this food. Your brain isn't designed to handle this. And further, when we eat this food, it causes disease in us that leads to lower levels of these chemicals to begin with, which makes our drive for them even higher. So the synthesis of these chemicals is dependent on several of the B vitamins, iron, magnesium, zinc, omega-3 fats, all of these things which tend to be deficient in these processed foods. So, this is the problem. We just end up perpetuating the problem. We consume these terribly addictive foods. We end up with lower levels of these neurotransmitter and hormones in the brain, and our desire to have them. We just end in this awful, awful loop.
There's just no nutritional value in a lot of these foods, is there? I mean, they're just basically empty calories.
Well, and that's the other problem. Exactly. So this actually compounds the problem significantly. So yes, we get inflammation and so on and so forth. But if we're missing out on these nutrients, then that's going to, in several ways, which we'll go into, will compound the problem even more. And the problem is, so first of all, junk food, the only nutrients that are really found in junk food are the fortified nutrients, the ones that they put in there because they know they're so horribly nutrient deficient to begin with that they don't have them. We also have this problem where we're discouraging people from consuming animal foods. And we know that animal foods are far more nutrient dense. And when I say nutrient dense, it's not just the quantity, but they're also bioavailable nutrients compared to plant-based foods. So take vitamin A for an example. The animal form of vitamin A is about
Mm,
12 times more bioavailable or active in the body than the plant-based form. 12 times more. So
mm,
in terms of that, there's really no comparison. And then the food that we have on top of that, because of our modern agricultural practices with pesticides and fertilizers and so on and so forth, all the growing plants have been able to leach all the nutrients out of the soil, which is what growing things do, the grass that cows eat or what have you, the crops that we eat, they need nutrients and they take it from the soil. And what normally happens is that this rich microbial diversity in the soil will actually break down the rock and the clay and the sand and release more nutrients to replace those nutrients that have been removed from the soil. But with modern fertilizers and the use of pesticides, we're actually killing the microbial elements within the soil that do this. So for some nutrients, our foods now contain 75% less of some nutrients than they did 50 years ago. You could eat an apple, and that apple is really not as nutritious now as it used to be. And that's a huge problem. And I'll tell you why it's a huge problem. Because when you're missing out on nutrients, that also makes you fat. So there was a study they did in 1975, and it had a pretty awful title, Elemental Balances During Intravenous Hyperalimentation of Underweight Adult Subjects. In a nutshell, sometimes the stomach, the gastrointestinal tract just doesn't work properly. So we might actually need, as doctors, to give people their nutrition directly into their blood. We put a cannula in a vein somewhere in their body and we put all the nutrients they need. So they did a study published it in 1975 where they experimented with some adults who were receiving this kind of nutrition, and they were trying to get them to gain weight. And so they basically gave them every single element in the feed that they thought they needed. So glucose, nitrogen, which is basically a surrogate for protein, potassium, phosphate, sodium chloride, so on and so forth. And then they experimented with just eliminating or reducing the content of one element at a time to see what the response would be. Now, the interesting thing is that when they took away the nitrogen or the protein, phosphate, sodium, or potassium, they actually found that it impaired or completely abolished the ability to form tissues like muscle or like bone. But here's the thing. So if these subjects were no longer able to form muscle or bone, they were still having the same amount of energy coming in. Where did that energy go? And I quote directly from the paper, weight gain continued despite zero or negative elemental balances. And what they stated this was largely adipose tissue. So simply put, if you're not getting enough nutrients, as this study elegantly showed, that it actually changes what you do with the energy that comes in. So we talk about this term called TOFI, thin on the outside, fat on the inside. So somebody who's TOFI, they're skinny, they've got no muscle in their arms and so on and so forth. They're weak, maybe an osteoporotic female with weak bones. Having low muscle and weak bones, you can still store things as fat. And that state can be driven by deficiency of nutrients, by a deficient nutrient intake. So interestingly, this is followed up, and one of the nutrients that we often don't talk about in these circles, which they did a lovely study on, was phosphate. In 2015, the British Medical Journal published a randomized control trial, a blinded randomized control trial on phosphate. And they actually found that when they supplemented with phosphate, that there was a significant degree of weight loss and reduction in waist circumference. There was nothing else, just a little, just a phosphate tablet. That's all they got as an intervention. So we often don't appreciate the fact that our nutrient deficient diet is causing us to become obese. There's another study that was a similar finding for females who were low in iron, and they gave them an iron infusion. And in this is also a randomized trial. And they found that when they gave them iron, they lost weight their good HDL cholesterol went up, their bad triglycerides went down. And this was all without any dietary or exercise advice. The simple fact of replenishing nutrients that the body needs, which is deficient on processed food and junk food diets, actually significantly improves our ability to lose weight.
What about magnesium? We hear a lot about magnesium, concerns about magnesium deficient in the soil, and do we have a widespread sort of epidemic of magnesium deficiency?
Yes, absolutely. So magnesium is essential for over 300 biochemical reactions. I can pick my biochemical textbook out there, and you start looking at magnesium, and you won't stop for a week because it's just involved in so many essential pathways. And magnesium was one of the nutrients which was studied in that 1975 study. Now, it wasn't shown to be as essential as phosphate and potassium and so on and so forth, but it was still shown to be important. And depletion of magnesium does have multiple effects on the body. And it's not just that. We can go through multiple nutrients. So iodine is a very common nutrient deficiency that I see in my patients. Boron, now boron is an essential nutrient that's not considered to be an essential nutrient. Now, what do I mean by that? The literature is very clear. We need boron, but we've sort of got a list of official essential nutrients, and boron's not yet on that list. Now, it will be. I predict in the next 5 or 10 years that medicine will come alive and will realize the importance of this nutrient, but it's not recognized yet. And when I test my patients, a good proportion of them are also deficient in boron. So the problem is we can't go testing every single nutrient in every single patient. So it's much better to just make sure that you're having as well balanced and nutrient dense a diet as you can. And what that really means is that we need to be eating animal foods. The other problem is, and this is a huge problem in my patients, that just because you're consuming a nutrient does not mean that you're absorbing the nutrient. So, I, for example, might find a B12 deficiency in a patient who's eating meat every other day. And what's actually happening is the absorption of B12 is very complex in the body. There's a lot of things that can go wrong. It's not unusual for people with, say, celiac disease. They end up with problems in their stomach and their small intestine, and areas where those nutrients, particular nutrients, get absorbed or affected. They might end up low in calcium, for example, or so on and so forth. So the way around this is to also understand that sometimes the foods we eat can cause inflammation, and it can affect our gastrointestinal system. So, for example, I've seen lots of patients who have been nutrient deficient despite consuming those nutrients in the diet. And the solution to the problem is not to supplement with more nutrients, it's to remove whatever is causing that inflammation. So, for example, cutting out gluten for a lot of people is very, very beneficial if you're shown to be deficient in nutrients. That chronic inflammation that you get actually makes a real difference. So, if we think back to that study I told you about iron deficiency, and we know if you're low in iron, because iron is needed for what we call the power plants of your cell. The mitochondria in your cell, they're what burn the energy. And iron is necessary for those to function normally. You just can't burn energy properly if you're deficient in iron. Now, there's a condition that is not well known in medicine, but it has been described in the literature since the 1970s, and it's called nutritional inflammation. And this is utterly fascinating. Basically, if you're inflamed, that can mimic a state of iron deficiency in the body. The notion is that most any pathogen that can infect us as a human also needs iron. So we've got an adaptive strategy where when we have an inflammatory trigger in our body, which historically has only ever occurred when we've got an infection, our body says, oh, I've got these inflammatory chemicals running around. It's probably an infection. I'm going to get all of my iron and I'm going to take it out of the blood and I'm going to put it into storage. And we've got studies that show that when we inject bacterial products into sub-volunteers, we can reduce the amount of iron circulating freely in their blood by 50% within 2 hours. This is an absolutely profound effect. And so, in essence, when we're inflamed, that creates a state of iron deficiency. And it also confuses things even more, because what do? Like, we can't just disappear the iron. I'm not David Copperfield here. So what do? Well, we have to put the iron somewhere. So we stuff this iron into storage, and that storage is called ferritin. So we often see ferritin levels go really, really high. And if you go to your doctor and the doctor sees you have a high ferritin, what are they going to tell you? They're going to say your iron levels are high. But the problem is they're only high because you can't use it. It's what we call a functional iron deficiency. And this is the nature of what nutritional immunity is. Nutritional immunity is that we lock away a nutrient to starve the bacteria, because if the bacteria and these other pathogens can't get to that iron, it's going to make it easier for our immune system to eradicate that infection. But here's the problem. What happens if you have inflammation from another cause? What happens if you're developing inflammation because you're having a whole heap of junk food? You still have these inflammatory chemicals circulating around in your body. Does your body know the difference between an infective inflammatory response and just a junk food inflammatory response? It does not. You still can end up, if you're eating a lot of these inflammatory foods, might be a lot of gluten, might be a lot of sugar, what have you, seed oils, then your body can end up locking iron away as well. And you can end up with this, effectively, an iron deficiency, starvation in a land of plenty. You've got lots of iron there, you just can't use it. So there is a bit of nuance to this, and it's not just a matter of saying you've just got to have the nutrient. You have to make sure your body is in a healthy state as well. And for that end, eliminating a lot of grains, and it's not just the carbohydrate content of grains that we worry about, but grains are inherently inflammatory, especially when you consider that they're often laden with oodles and oodles of pesticides. How many people understand that in Australia, farmers are allowed to spray a crop of wheat with Roundup 6 days before it gets harvested and made into bread? Our food supply now is not what it used to be.
So we've talked about all the sort of the things that stop you losing weight and or cause you to gain weight and so on. So if you just had to summarize advice you would give to someone who wanted to lose weight and say, well, what sort of diet should I be eating? What would you say to them?
Okay, so number one, low-lying fruit is seed oils. And the reason for this is very clear. So if somebody has to try and give up sugar and carbohydrates, there's a whole lot of addiction going on there, because we know that sugar is addictive. It's very, very difficult. But seed oil, you don't really have, there's no more addiction from seed oil than there is from saturated animal fat. You can give up seed oil and replace it with something that's far healthier and far less inflammatory without suffering any cravings or any withdrawals at all. This is sort of, the no cost change to your diet. There's no downside to doing this. You're not going to have to wean yourself off it. You're not going to have to contend with cravings. You're not going to have to retrain yourself. The low-lying fruit, the logical thing, the very first thing that you ought be eliminating from your diet are seed oils. Number two, sugar.
Further. So seed oils are really found in two sort of ways, I guess. One is cooking oils, so all the different safflower oil and canola oil and so on, and then secondly in processed foods. So
every processed food.
Every processed food, yeah. So basically, that's the first thing you do is stop processed foods, and then change what the oil that you're cooking from the seed oils to what would you recommend?
So the single best oil that I personally use is called tallow. So tallow actually comes from around the kidneys in an animal. And the reason we like tallow is because it's very resistant. It's even more resistant to oxidation than other fats are. So tallow, we call it, might be suet made into tallow, but what have you. That's the fat. Suet is the actual fat around the kidneys. And when you heat it up and put it into a liquid, we turn it into tallow. So tallow is the number one.
Right. Okay. Right. Continue on. Sorry to interrupt, but tell me number two.
Well, number two is just sugar. Now, we do distinguish. Now, why we do we get a bit loose. We talk about glucose as being sugar and so on and so forth. But there really is a worse kind of sugar. There's glucose and then there's fructose. And sugar that contains fructose is far worse and far more deleterious. It's 7 to 10 times sweeter than glucose, which makes that addictive potential is just off the scale. It is much more likely to damage our proteins by a process we call glycation. It's just really, it's nobody's business. So
where is fructose? Where
fructose
would you find fructose?
is in anything that is particularly sweet. So anything that we'd normally consider sugar. So we have table sugar, that's 50% fructose. Anything that lists sugar or any of the 50 odd pseudonyms, such as organic agave, anything that says syrup is a sugar. Sometimes they might try and get around things, use malts or what have you. But the point is that, yeah, you just have to look on the nutrition label and look where it says sugar. They will generally distinguish between fructose containing sugars on a nutrition label. That will be under the sugar row versus the glucose containing complex carbs or other carbs, which they'll just list as a carbohydrate. So the simple fact is, if you're eating a food that comes with a nutrition panel on it, there's a very good chance it's processed food. The chicken in my fridge, the eggs in my fridge, they don't have nutrition labels on them. They're real food.
Yep.
So that's that number 1 and 2. Get rid of the seed oils, and that's so easy. I can't impress. Like, you can do this with no effort. Well, there is some effort there, but it's not physiological effort. You're not fighting cravings. You're not going to be beating yourself up over this one. That's just so easy. Everybody should do that straight up.
Okay. Now, obviously, the biggest development in weight loss and obesity and so on in the last few years is the GLP-1 drugs, Ozempic, and I think everyone's heard of it's the most commonly one, Ozempic, Wegovy. There are all sorts of different drugs, and everyone says, "Oh, this has revolutionized the weight loss industry," and it's everyone should be on Ozempic, and everyone in Hollywood's on Ozempic, and we should all be losing weight through Ozempic, and I think we all accept that these drugs are effective in weight loss. There's no doubt that they are effective, but I certainly have some concerns about them. And what's your feeling on these drugs?
We are creating an epidemic of osteoporosis and fragility that is going to be unseen of to this date. In future generations are just going to fall over and snap their hips, and here's why. So, and this is drug company funded research. So one of the studies where they're actually using to submit to the FDA to get the original approval for these drugs, they looked at their weight loss, and they actually did DEXA scans, body composition scans, and they were having a look at how much muscle and how much bone and how much fat they actually lost. And they found that something like 40% of the weight that the subjects lost was actually muscle or bone. Now, and that is absolutely huge, especially when you consider that we're often using them in people at a stage in their life when we'd really want to be optimizing their bone health. We don't want to be setting them on a pathway of osteoporosis.
How does that compare to when you lose weight through, say, a low carb diet, for instance? What sort of a percentage is from muscle and bone then?
Look, it varies. It's in a lot of cases, you can actually increase your muscle and bone on a ketogenic or low carb diet. It will often be associated with some muscle loss, but it would be, it would be less than, 3%, 5%. It would generally be very low. And if you're prepared to make sure that you are having a higher protein form of diet, you don't necessarily lose any muscle at all. And frequently, I have patients who, when we do this BMD, bone densitometry scanning, DEXA scanning on them, they actually increase their bone density at the same time that they're losing weight. And that's simply not possible. So this is why we tell people to exercise and eat protein if they're taking Ozempic or something like that. The reason is because we know it's so bad for the bone health, it's so bad for muscle. We know that lean muscle mass, in terms of biomarkers, is probably one of, if not the strongest biomarker that can predict longevity. So what is causing these people's muscles to waste away doing for their overall longevity? Now, here's the other problem though. So we know that, over this 12-month period of this study, we had this wasting. Then they stopped it. Now, there was no suggestion at all that they had actually reached the limit of muscle or bone loss. The assumption being that what was implicit within this study was that if they had continued taking this drug, then bone loss and muscle loss would have continued to accrue. Then they actually did a follow-up to this study where after the 12-month period they stopped it, and then they had a look at the weight regain, or if there was any, after 12 months of stopping it. And invariably, they found there was something like 40 to 60% of the weight that was initially lost had been regained. Now, interestingly, they did not present the DEXA scanning data on whether the weight that they regained was fat, muscle, or bone. And for the life of me, for a drug company funded study, if it had have been muscle and bone that had come back, I imagine they would have been singing it from the rooftops. So we'll just let that one there. So what we know, and anybody's welcome to correct me if I'm wrong, is that the longer you take these drugs, the more bone you lose. So you can't stay on it forever because you're just going to end up with no bone, weak bones. And when you do eventually stop it, on the balance of probability, you're going to regain the fat, but your bones aren't going to get any stronger. Now, we have an alternative. You can go on a ketogenic diet where you can actually increase your muscle mass, you can increase your bone strength, and you can lose the weight at the same time. And all the important biomarkers of health that are associated with longevity will improve. For the life of me, I don't understand how anybody in good conscience can prescribe these drugs for patients wanting to optimize their long-term health.
Okay. Well, that's you wouldn't be as popular as a Hollywood doctor, I'm afraid, Paul. You'd be out of a job. But anyway, look, I can understand why it's very attractive. I mean, if people have tried diets and things, they probably haven't had a good go at a ketogenic diet. But it seems, and it's marketed very well. It's very attractive. Oh, I just have to have this injection. I can eat whatever I like. I don't have to exercise. I can just inject this thing once a week and I'll lose all this weight. I get that. That's very, very attractive. But as you say, no one talks about the negatives. I read a whole sort of 2-page article about it yesterday in one of the medical things about the benefits of these drugs. And I kept looking, scrolling through the article. Oh, when are they going to talk about have a balanced view? When are they going to talk about the negatives? And got to the end of the article and nothing.
Yeah.
So I think, where obviously the drug companies have a massive investment in this, and they're making a lot of money out of Ozempic, but we do need balance and muscle. I think, you mentioned you focus on bone, but I mean, we focus enormously for older people in particular on maintaining muscle mass for all the sort of reasons of preventing falls and all this sort of stuff. And yet, it's being sabotaged by these drugs that you can't maintain muscle mass. I mean, they're saying, oh, you've got to go if you're on Ozempic, go to the gym, do all this, muscle building exercise and so on. But that's really saying that it's a massive problem.
There is a vernacular phrase for that.
We won't go there. Okay.
But there's a couple of questions. I've been looking at some of the social media. So there's a couple of things that I just wanted to say briefly from the Defeat Diabetes discussion groups. So there was some comments about people who have actually lost weight on a healthy diet, and they're actually concerned about losing too much weight.
Yep.
Now, I know you use the phrase, I know Dr. Ken Berry used the phrase of attaining an optimal weight. It's an optimal weight diet. So if you're too skinny, it can increase weight and so on and so forth. But there is one key exception here. And there's a condition of type 1 diabetes that can often afflict adults. So about 10% of people diagnosed with type 2 diabetes may, in actual fact, have a type 1 variant where there's not enough insulin. It's got a bit of a funny name. We call it LADA, or latent autoimmune diabetes of adulthood. Now, the problem with LADA is that while you may or may not have insulin resistance where your receptors aren't working properly, you also have a deficiency. Your pancreas simply cannot make enough insulin. And you'll recall we talked about how type 1 diabetics present. They present emaciated. So if you're a diabetic and you have unexplained weight loss, or you can't put on muscle, or so on and so forth, then I encourage you to go to your doctor. Please speak to your doctor about that. So if you're having trouble gaining weight, it's not necessarily a function of the diet. It could actually be a function of your disease. So please get checked out.
How would they determine whether they've got LADA or not?
Well, so this is obviously what their doctor would do.
Yeah.
So the doctor would do some blood tests. So the first blood test that most doctors will do is called looking for something called antibodies. We look for evidence that your immune system is actually attacking the pancreas, the organ that actually releases insulin. And if we see that, then we say suspicious that your insulin levels would probably be low. The gold standard test, which is unfortunately not done as widely as it should be, is what we call a Kraft test. It's an oral glucose tolerance test, which is like the test you get when you're pregnant, except we also add in insulin. So what should normally happen is that if your glucose level was high, your body should say, oh, I need to lower that glucose level, so I'm going to release a certain amount of insulin. So if at any time over this 2-hour test we see that your glucose levels are high and your insulin levels are inappropriately low, then we know that your body is struggling to release enough insulin. So that's how you'd tell. But yeah, if you're having trouble gaining weight, or if you're losing excessive amounts of weight beyond what you feel is reasonable, then please go see a doctor.
Okay. And you had another point you wanted to make?
Yeah, so there's been a lot of discussion recently about seed oils and whether or not seed oils are actually healthy. And the problem is that nobody has ever done a study where we've actually removed seed oils from the diet to see what kind of benefits you get. But there have been 4 randomized controlled trials where they've actually added seed oils into the diet. And every single one of those found deleterious effects. So there was one, the first one was 1965. And that showed that when they gave people corn oil, there was an 86% increased risk of heart attack. And there was another one, a 1968 study, that showed that while the seed oils did lower cholesterol, they did so at the expense of making you more likely to die. We've got a study closer to home called the Sydney Diet Heart Study, and they found that in males who were given seed oils, their chance of dying increased by 62%. And then we've got the largest one, 48,000 females, called the Women's Health Initiative. And that found that there was a 26% increased risk of having cardiac problems. And then when we followed these subjects up later on, after the initial 8-year period, that 26% had increased to 61%. So what we've got is we've got clear evidence that introducing vegetable and seed oils into the diet is problematic. What we don't have any clear evidence that removing the seed oil, simply because these studies haven't been done. And as you know, there's a few of us who are in the process of trying to get some of these studies done. But on the balance, my interpretation of the literature is that it's likely, if not certain, that seed oils are toxic. And I think future research is going to confirm that.
And so once again, those seed oils are in the different vegetable oils that we all basically cook with, and they're in pretty much all processed foods have these seed oils. And obviously, the other important thing is the ratio between the omega-3 and the omega-6. And so, just as it's important to reduce the amount of the seed oils, it's important to increase the amount of the healthy omega-3 fats, isn't it? The fatty fish.
Well, I've got a bit of a slightly different view on that. I don't think there's anything inherently problematic about omega-6 fat. The problem is that most seed oils that we consume are very, very rich in omega-6, and that tends to skew it. So when we see that people with high levels of omega-6 in their blood are much sicker than people with low levels of omega-6, I believe that purely is just because they're consuming this large amount of seed oils themselves. I don't think the omega-6s themselves are inflammatory. I think it's other chemicals inside the seed oils which are problematic.
All right. So what are they?
Well, we actually have, so cholesterol is essential for life. So for mammals, for humans. Now, plants have a different type of cholesterol. We call it plant cholesterol or phytosterol. And that's similar to cholesterol, but different. So sometimes because the body can absorb it a little bit, it absorbs in a normal state 1 or 2% of it, it can actually affect how our body produces LDL and cholesterol and so on and so forth. So sometimes we use these plant sterols therapeutically to lower cholesterol. The fact is, though, that there's no research that has ever proven any kind of mortality benefit from taking these plant sterols. And there's lots of research that indicates there's significant harm. So when we look at people with advanced heart disease and we do autopsy studies, we can often see layers and layers of this fake plant cholesterol lining the arteries of people who have had heart attacks. So I think it's more chemicals like phytosterols containing within seed oils that are more harmful rather than the omega-6 themselves. Omega-6 and omega-3, they're both essential for life. They're both essential fats. And I don't think omega-6 is inherently inflammatory. It just so happens that we normally consume it from seed oils.
Interesting. Great. We've run out of time. We did have some questions. I think I've covered most of the questions in the sort of discussions already. But we've got a lot of other topics we want to talk about, haven't we, Paul? So over the next few months, we're going to tackle blood pressure. That's another big topic, and we've got a few other things up our sleeve, haven't we? That we'd like to talk about. So as well as obviously we always have some interesting guests as well, both Australian and international. So Paul, once again, thank you. It's always fascinating to listen to your incredible knowledge on these issues, and I'm sure all of our listeners really appreciate it. Thank you all for listening. We'll be back next month with another webinar. We'll let you know where and when. But in the meantime, thanks for listening.